Hey guys, Nicola here. So I'm a Unity and indie game developer with over 5 years of experience and also have professional development experience with AR and VR applications as well as professional games. So what I'd like to talk to you today about is Unity scene loading and memory management. And these two things are very much connected because the more memory your game needs, the longer the scenes are going to take to load, and we want to keep basically the memory only loading what we need at any given time, and we want to keep it as small as possible so that we can improve scene loading times and just general performance. So what I want to talk to you about is basically how I solved some issues with loading and memory for my game specifically. This might differ from game to game, but hopefully this will give you an idea of how you can solve this for your own project as well. I'd like to take a quick second to give a shout out to my current game called Mortal Sin. This is an action horror roguelike with stylized graphics, very gory, visceral combat, and procedurally generated levels. So if you're interested in this video and kind of where this game comes from, I'd highly recommend you to give it a wish list on Steam. That would help me a lot. Anyways, on to the video. So essentially in my game, just to give you an understanding of what the need is, it's a procedurally generated action horror roguelike game. So the levels need to be instantiated at runtime. I can't have it baked into scenes or whatever. I basically have these pieces that can be spawned in at any given time. So what I did was I have this prefab here, for example, and this has reference to these maze objects, which in turn has references to a bunch of other prefabs, basically spawnable objects like barrels, enemies, that sort of thing. So now if you're doing something like this, like let's say you have a monolithic prefab, like in this case where you have all these references, what actually happens when you load a scene in Unity is that not only is it going to load anything that's already kind of fixed in that scene, like let's say like an environment that needs to get loaded in, it's also going to look at all the prefabs in your scene, all the prefab references. And it's going to say, oh, okay, well, you have maze generator. Let's see. Maze generator has a link to level sets, which is these individual maze prefabs. And then it's going to grab basically all the references from this prefab, and it's going to load that right into the scene as soon as everything starts. So it's easy to kind of not understand that that's actually what's happening, and so that's why you have to be careful when you have especially these big prefabs, or even if you use a scriptable object, it's going to be the same thing, right? Because it has these references, they're linked to the scene, and then Unity has to load in all those textures, all those meshes associated with it. So what I did in my case is I staggered the loading a bit. So as you can see, I put a separate maze generator scene, which only has this prefab, this like monolithic prefab, which has all its references. And so what I can do is I can first load in my graveyard scene, which is basically the hub world for my game. So you go here, and I can just show you real quick. You basically move around in this scene, and you can kind of pick where you want to go. So let's say I want to go to the cave. Cave's down here, and then the main dungeon levels are over there. Basically, I can stagger the loading so that first the player can walk around in the hub world, but in the background, the scene with that prefab with all the procedurally generated tiles and stuff, that is going to get loaded afterwards. So I'm not stuck on the loading screen. I have a little bit of buffer in between. So essentially, yeah, you want to do additive scene loading so you can kind of stagger all these different scenes with references, so you don't have to force the player to all load at once. So to set up your additive scene load setup, this is just an example. This is what I did. You could do something completely different, but basically this is the first scene in my game. It's a loading scene. It's very minimal. It just has this loading bar, and this scene is basically always active in the game on top of all the other scenes, and it's going to control, it has this loading component. It's going to basically funnel all the loading requests into this component. And it's also going to handle fades and transitions and stuff. So if we can see here, if we start on the loading screen, the first thing it's going to try to go to is the main menu. So, and then you go from here, loading screen is still active, or loading scene is still active. As you can see here, it fades in, fades out, and then we're into the graveyard. So yeah, loading scene is always active. And what that's going to help us with is we're kind of managing all of the loading requests. So it goes through this one thing. So we can do additive scene loads. We can kind of stagger the scene loading and all that. So yeah, basically loading, then it goes to main menu, and then it goes to graveyard. But then what happens at graveyard is that it loads this maze generator scene, which has all of the instantiated prefabs for the procedurally generated levels. So if we look in the code right here, I put a 10-second delay so it's more obvious, but essentially we'll load the graveyard scene, which is on the game, which is where the game manager starts here, and then we're going to do 10-second delay. Again, it's usually shorter. I usually just do this small delay, but just for the sake of example, we do this, and it's going to additively load the special prefab scene. And that's going to save a lot of memory to load in at once, basically. So I can show you real quick actually what that looks like if you're looking at the profiler. So if we look here, and then we open the profiler. So if we look here at the memory count, we can see, hold on, let me adjust the volume real quick. We can see here at the memory, we're sitting at about 468 megabytes used memory, and that's just with this main scene loaded and the loading scene. So if we push start, we can see the memory is going to spike up as it does because we're loading an actual level. So if you see now, we're at about 1.58 gigs, but then now you see it's climbing up again. That's when the maze generator scene gets loaded additively, and that's an extra gig, which is huge. So basically what we're doing is we're splitting the load in half. You go in, and then you have 1 gig to load for the main hub world, and then the player's already in, they're walking around, they're not stuck on the load screen, and while they're walking around in that time, we kick in the second load, which is the additive scene load for the maze generator scene, which is literally just that prefab with all the maze spawnable references. And now you can see we can go here, and everything's loaded pretty seamlessly. Enemies are there, and environment and all that. So yeah, that's one way to stagger your loads. Basically, you split the references into different scenes. You have your main scene with the environment and all your manager, player, all that, and then you have another scene with, like, let's say hefty scriptable objects references or prefab references. Your data basically you can push to another scene. But what I also want to show you is kind of interesting, and this is kind of a big gotcha of Unity, is once you've loaded something in, so let's say we're sitting at 2.4 gigs right now, just because you unload the scene, so here I'm unloading the scene, we're going back, right now it's just the loading scene and the main menu scene, and you can see here, I'm still at about 2.4 gigs of memory. So that memory actually stays on forever once you've loaded the scene. So if you don't want this to happen, what you need to do is called this resources.unload unused assets. This is a very slow call, but basically you'd put this at the end of once the level is loaded. So it'll go through, it'll clean up, it'll say, okay, that scene's not loaded anymore, I don't need these textures or whatever, so I'm going to get rid of that. So that's one option you have. In my case, one advantage is, since it's already loaded, the second load time is going to be much faster, right? Because we already have that stuff loaded into memory. So it's actually, it can be an advantage, but you just need to be careful, because if you're making a very large game especially, you need to be very conscientious about how you're cleaning up unused resources and memory that you don't need. Otherwise, you're literally going to just hit the memory limit, which modern computers have a lot of RAM, but it will add up. And especially if you want to be on console or mobile, you have to be very conscientious about this stuff. So that's pretty much the main thing. It's staggering, and kind of staggering the loads by splitting up your scenes into additive scenes. And then you can optionally call unload unused assets to clean up memory that you don't need anymore. The other option is to use addressables, which is a relatively new system, And I don't want to get super into that. That probably takes its own video. But that's another way to kind of load in textures you need and kind of control through script when you load and unload these things from memory. So that's basically the main gist of it. The other main thing I want to talk about is a quick win you can do. So this is a very common issue that plagues a lot of first-time developers when you're doing scene loads, which is the audio settings. So basically, just to be real brief, for long tracks, so for songs, you want to have either streaming or compressed in memory as the setting. And that's going to make it so that every time there's a load, it's not going to try to decompress the audio as part of that load, and instead it's going to take a little bit more CPU time to decompress it when it's actually being played. And this is going to save a lot of time on your scene loading. So again, you want streaming or compressed in memory. For shorter sound effects, like hits and stuff like that, you can just put the default, which is decompress on load, and then basically any of these settings are fine. Vorbis, I'm experimenting with AD PCM right now, but that's going to make a huge difference. Basically, these big audio clips, by default, Unity is going to set it to decompress on load, but you don't want that. You want one of these two. So as far as audio goes, that's going to help a lot with the loading. And essentially, that's the main part of it. You have the audio settings. That's a quick win. And then you want to be careful about your prefab references, because just because it's not instantiating the scene doesn't mean it's not loaded into memory. Basically, anything that prefab is connected to, it's going to load into the RAM, and it's going to be included in the scene load. So you need to be careful with that. And again, there's much better solutions than what I posted here. Ideally, you'd use addressables, and you'd only load things you need at any given time and unload it. But this is kind of a way to get a quick win and shorter load times. Basically, split the scenes and make sure your audio settings are set correctly.